Okay, we have here another integral. This one's from UNSW 2019. Problem number 2. We have the integral from -1 to 1 arc sine x plus arc cosine x dx. So I kind of just want to walk through the steps of this. When we have these arc sine functions, it's kind of useful to draw our triangle and get a sense of it. What I'm going to do is I'm just going to say, let's call our arc sine equal to y. Arc sine of x is equal to y, and that means x is going to be sine of y. So then when we draw our triangle to get some perspective on this, we'll draw a right triangle, 90 degrees. Well, that's the definition of a right triangle. So there's a 90-degree angle there. We'll draw in our angle y. So if sine of y is x, we can write that as x over 1 to get a little ratio going. So we'll have x for this side, 1 for this side. This side, you can find this from the Pythagorean theorem. This side must be 1 minus x squared. Now from here, it's interesting to know, okay, so the sine of y is opposite over hypotenuse, so x over 1. So that means what we can say is the cosine of y is going to be adjacent over hypotenuse. So cosine of y is going to be just our square root of 1 minus x squared. Okay, that means that y also can be written as the inverse of our cosine of the square root of 1 minus x squared. But I don't know if that's really what we need. That's not really what's going to help us here. We can notice, though, we can just call this other angle. So we only have 3 angles. With triangles, got 3 angles, right? We've got another angle here, t. And then we can kind of make some other conclusions. Like if we notice, so first of all, we know that the sum of the angles of a triangle is 180. And if that's 90, so we know that t plus y plus our 90 has to equal 180. Well, that means that t plus y, or y plus t, equals 90. And we can express that as pi over 2. But what we need to do here is make some use of this angle t. And you'll notice, so that the sine of t would be opposite over hypotenuse. So sine of t is going to be square root of 1 minus x squared. Cosine of t, adjacent over hypotenuse. Cosine of t is going to be x over 1, or just x. But then if we want a nice expression for t, we can take the inverse here, and we'll see that t equals our cosine of x. And that puts us in a good spot because we've got a value here for our angle y. We've got our angle t here, and we know what this equals. So we can just plug this back in, and we're going to see that plugging in y, we're going to have arc sine of x plus t cosine of x equals pi over 2. But that's just our integral, right? That's what we have here. So all we're doing is we're integrating 1 to -1 pi over 2. That's just a number, it's just a constant. So when we do this integral, we have pi over 2x from 1 to -1. And we'll just evaluate this thing. Plugging in a 1, we have pi over 2 minus pi over 2. It's just a plus. Adding those together, we get our solution, pi. And that's it, our answer is pi. Okay, like that one, fun problem. We'll stop it there. Thanks for watching. Have a good day.